Your PC is basically a space heater that accidentally does math. Modern CPUs can spike past 100 degrees Celsius in seconds without cooling. That's boiling water temperature inside your computer. And the solutions range from a $3 tube of grey goop to a full custom plumbing rig that costs more than your GPU. Cooling is the only thing standing between your build and an expensive paperweight. Here's every method you need to know. Thermal paste. This is the unglamorous foundation of every cooling setup. It's a grey, toothpaste-like substance that sits between your CPU and whatever cooler you're using. It looks like nothing special, but without it, your cooler is basically decorative. Metal surfaces look smooth to your eye. Under a microscope, they're full of tiny ridges and valleys. Those microscopic air gaps are terrible at transferring heat. Thermal paste fills every one of those gaps. Think of it like caulking around a window. The window does the real work, but without the seal, you're leaking everywhere. The spec that matters is thermal conductivity, measured in watts per meter Kelvin. Most decent pastes land between 8 and 12 W-SEM-K. The expensive stuff pushes past 14. For gaming or everyday use, any reputable paste from Noctua, Thermal Grizzly, or Arctic does the job fine. You don't need the fancy tube. The biggest myth is that you need to reapply it every few months. Good paste lasts years. If your temps aren't climbing, leave it alone. Stock coolers. These are the coolers that come free in the box with your CPU. They're small, lightweight, and, honestly, a little underwhelming to look at. AMD's Wraith series actually earned some respect with decent performance and RGB lighting. Intel's stock coolers have historically been less inspiring, like the free earbuds that come with a phone. Technically functional. The job of a stock cooler is simple. Keep your CPU alive at its default settings. Most use a small aluminum heatsink with a fan bolted on top. They're rated to handle the CPU's base TDP, usually somewhere between 65 and 105 watts. For office work and light gaming, they're perfectly fine. Where they fall apart is sustained heavy loads, video editing, long gaming sessions, or anything that pushes the chip hard. The fan ramps up, noise gets noticeable, and temps start creeping toward the limit. The mistake people make is thinking the stock cooler handles overclocking. It doesn't. If you're pushing clocks higher, upgrade immediately. Tower air coolers. This is where PC cooling gets genuinely impressive. A tower air cooler is a big metal heatsink with heat pipes running through it and 1 or 2 fans strapped to the sides. They look like tiny skyscrapers inside your case. Heat pipes pull thermal energy away from the CPU and spread it across rows of aluminum or copper fins. The fans push air through those fins and out of the case. No pumps, no liquid, no real failure points, just physics and moving air. The specs to watch are heat pipe count, fin surface area, and fan size. A solid tower cooler with 4 to 6 heat pipes handles 200 plus watts without breaking a sweat. The Noctua NHD15 has been the gold standard for years. It runs quiet, performs beautifully, and looks ugly in the most endearing way possible. If you've got one, you know exactly what I mean. For most gamers, a mid-range tower cooler between $30 and $50 is the sweet spot. Massive thermal headroom without the complexity of liquid. The only real catch is size. These things are enormous. Always check your case clearance before buying. Otherwise, you'll discover your side panel doesn't close. Like trying to park a truck in a compact spot. AIO Liquid Coolers. If tower coolers are the reliable workhorses, AIOs are the sleek sports cars. An AIO stands for all-in-one. It's a closed-loop liquid cooling system that comes pre-assembled with a pump, radiator, tubes, and a cold plate. You don't fill anything, you don't plumb anything, you bolt it on and move on with your life. The liquid absorbs heat from your CPU, travels through tubes to the radiator, gets cooled by fans, and cycles back. Same principle as your car's cooling system, just miniaturized for your PC. Radiator size is the main spec here. A 240mm AIO uses 2 120mm fans and handles most CPUs without drama. A 360mm uses 3 fans and tames even the hottest chips on the market. For gaming, 240mm is usually plenty. Content creators running sustained workloads should look at 360mm. Prices range from about $60 to well over $200 depending on brand, size, and how fancy the pump head display is. Some of them have full LCD screens now. Because apparently your cooler needs a personality. The common fear is leaking. Modern AIOs from reputable brands are extremely reliable. Pump failure after 5 or 6 years is far more likely than any leak. Custom loop liquid cooling. This is the deep end of the pool. A custom loop means building your own liquid cooling system from individual parts. You choose the pump, the reservoir, the radiators, the fittings, the tubing, and the coolant. Then you assemble everything, fill it, leak test it for hours, and hold your breath. It's basically installing a plumbing system inside your PC case. The upside is real. Custom loops cool your CPU and GPU simultaneously. They use larger radiators, higher flow pumps, and thicker tubing for superior heat dissipation. The performance ceiling is genuinely above what air or AIO cooling can reach, especially for extreme overclocking or high-wattage multi-component builds. But here's the reality. A decent custom loop starts around $300 and easily climbs past $500. You'll spend hours planning and building. Maintenance means draining and refilling every 12 to 18 months. For most people, this is massive overkill. A good AIO or tower cooler gets you 90% of the performance for a fraction of the cost. The myth is that custom loops are automatically better. They're not. They're better at the extremes. For the average build, they're an expensive hobby project, case fans and airflow. Here's the cooling method everyone has but almost nobody thinks about. Case fans are the fans mounted directly to your PC case. Front, back, top, sometimes bottom. They don't cool any single component directly. They manage the overall airflow inside your entire system. Think of your case like a room with no ventilation. Your CPU cooler and GPU are blasting hot air. If that heat just sits there, everything bakes together. Case fans create a flow path. Cool air enters through the front or bottom, passes over your components, and hot air exits out the back and top. The spec to care about is CFM, cubic feet per minute. That's how much air the fan actually moves. Fan size matters too. A 140mm fan moves more air at lower RPMs than a 120mm, which means less noise. The ideal setup for most builds is 2 to 3 intake fans up front and 1 or 2 exhaust fans at the rear and top. Positive pressure, slightly more intake than exhaust, helps keep dust out. If you've never cleaned your dust filters, go do that right now. I'll wait. The biggest mistake is ignoring fan orientation. If your fans are fighting each other, your airflow is chaos. 5 minutes checking the arrow markings saves real thermal performance. Liquid metal. This stuff is not for the faint of heart. Liquid metal is a thermal interface material, same job as thermal paste, but made from a gallium-based alloy that stays liquid at room temperature. It looks like mercury and conducts heat like nothing else. Thermal conductivity sits around 70 to 80 W to Cunham K. Regular paste does 8 to 12. It's not even the same conversation. Liquid metal can drop CPU temps by 10 to 20 degrees Celsius compared to standard paste. That's a huge gap for overclockers and laptop modders trying to tame thermally choked chips. But applying it is like performing surgery with a tiny syringe. One wrong move and things go badly. Liquid metal is electrically conductive. Spill it on your motherboard and you're looking at a short circuit. It also reacts with aluminum, so copper or nickel-plated surfaces only. For most builders, high-quality thermal paste does the job without the risk. Liquid metal is for enthusiasts who've maxed out every other variable and want those last few degrees. The myth is that it's the obvious upgrade from paste. It's not. It's a specialized tool with real consequences if you get it wrong. Phase change cooling. Now we've left normal PC territory completely. Phase change cooling uses the same principle as your refrigerator. A compressor circulates refrigerant that absorbs heat as it evaporates and releases it as it condenses. Strap that system to a CPU and you can push temperatures below zero. We're talking sub-ambient cooling. Temperatures genuinely colder than the room your PC sits in. Competitive overclockers use phase change units to push CPUs far beyond their rated limits. Systems running at -30 or -40 degrees Celsius aren't unusual in that world. World record attempts almost always involve phase change or liquid nitrogen. But this is absolutely not a daily driver. Phase change units are loud, expensive, and power-hungry. A decent unit costs $500 or more. It sounds like a mini fridge humming right next to your desk, because that's essentially what it is. Condensation is a serious concern too. When your CPU runs colder than ambient air, moisture forms on nearby components. Without careful insulation, that moisture kills your board. For 99% of PC builders, phase change cooling is completely irrelevant. It exists for competitive overclocking and pure bragging rights. The myth is that extreme always means better. Phase change is the most extreme option, but extreme and practical are very different things. So there you have it, from a $3 tube of thermal paste quietly filling microscopic gaps to a phase change compressor pushing your CPU below freezing. PC cooling goes way deeper than just slapping a fan on a heatsink. Whether you're perfectly happy on a stock cooler or you're planning a custom loop that costs more than your monitor, there's a right answer for every build and every budget. What cooling setup are you running right now? Drop it in the comments. I'm genuinely curious how many of you are still on stock. If this video helped you understand the options, hit that like button. It really does help the channel. Next up, I'm breaking down every type of PC case and why your choice matters way more than you think. Click the video on screen right now.